to the preacher curl?
I want to revisit that a little bit too, because I brought some slides that help explain a little bit better what we were talking about.
All right, yeah, we can start.
Okay, so you know, his comment was that there's nothing wrong with stretching the bicep during a preacher curl. And so when we last left off, I said the preacher curl does not stretch the bicep. And I've never said that what is wrong with the preacher curl is that it stretches the bicep. In fact, the bicep doesn't actually stretch until you put your arm behind your back. So it's not a matter of stretching the bicep. It's a matter of mechanical disadvantage. So I brought some slides that I'll show you that are from the book in the chapter where we talk about mechanical advantage and disadvantage. But so the first slide we're seeing here is basically it's a lever device that I typically use when I do my seminars. And if it looks kind of funny, it's because it started off as a seated calf raise machine. It's an actual device, and I chopped off the seat and I chopped off the part that holds your knees, that's under your knees or on top of your knees actually. And then I welded these little loops on the top of that bar to show how the lever length and the lever direction of pull is altered. So what I say to the audience is imagine that this lever arm is your forearm. And this thing on the left over here, which is where the weight is your hand. I'm going to put a 10-pound weight in your hand, and then I slide that plate on there. And then this pivot on the other side, that's your elbow. Okay, so imagine this is your forearm held parallel to the ground, horizontally. That's your elbow. That's the weight in the hand. Now imagine that your bicep is pulling on that forearm. How much is your bicep holding when you're holding a 10-pound weight? And of course, it's kind of a trick question. So I take the scale that I use with a hook and I put it on that very first hook. And it shows close to 10 pounds because I'm basically pulling from where the wrist would be, right? But that's not where the bicep pulls from.
Right.
The bicep pulls way on the other end of the forearm bones near the elbow. So then I keep moving the little scale down to each hook. And each time I move it up, it goes 27, 34, 55, 66, blah, blah. The next slide you'll see there is by the time I get to the very last hook, it measures 112 pounds. So that's how much your bicep is actually pulling. The force that it's loaded with is about 112 pounds when you're holding a 10-pound weight in your hand and your forearm is horizontal. And what I emphasize when I do the seminar is I say, now notice that I am pulling perpendicular to the forearm. The forearm is horizontal, I'm pulling vertically or pretty close to vertically, right? That's called mechanical advantage. And it's called that because what it means is that all of my effort is being used to pull that lever in the same direction that I want that lever to go, that lever can go, which is up. Watch what happens when I pull from an angle. So on this next slide, you'll see that I am pulling from a 45-degree angle, halfway between vertical and horizontal. And now the amount of force that scale shows is 220 pounds. It's essentially doubled, even though that's still just a 10-pound weight in your hand. Now, this is measurable. This is provable. This is not theoretical. Anybody can do this test, and you will see that when you pull from a non-perpendicular angle on a lever, you have to use more force. And the reason for this is because we still need 112 pounds to go up. But now, since I'm pulling halfway in and halfway up, only half of my effort is being used in an upward direction, and the other half is being used in an inward direction. So imagine that the change of angle that your bicep would pull on your forearm would double, even though the weight in your hand has not doubled, just because you're now pulling from more of a mechanical disadvantage. It's not the most extreme mechanical disadvantage yet, but you can see that already it's doubled.
Okay.
So on this next slide, you'll see I'm pulling from what would be a 20-degree angle, almost parallel to that forearm. And this would be about 9 times more load that I would have to produce in order to make that 10-pound weight up. Okay, so now look at this next slide, and you can see what we're talking about. When your bicep is pulling on your forearm from that mostly parallel angle as it is there on the left, and I've circled the attachment of the bicep tendon on the forearm, you can see that it's pulling mostly parallel to that bone. And on the right, I'm not quite pulling it not with a 90-degree bend in my elbow yet, but you can see the mechanical advantage that bicep tendon is gaining. So when you do a standing curl, you start off with a mechanical disadvantage,
right?
Which means that any amount of force that you have on there, even the smallest amount of force, is being magnified 9 to 10 times as much as it would be if you were pulling perpendicular to the forearm.
Mhm.
That's why we recommend that you start your curls with a mostly vertical forearm, meaning upright curls, dumbbells, cables, that sort of thing. And this is what's wrong with the preacher curls. So on this next slide, you see me sitting in a preacher curl bench. I've got an easy curl bar there in my hands, no weight on it, just to show you how straight my elbow is. And you can imagine my bicep tendon pulling on my forearm bone. Now that you've actually seen the anatomical illustration, you can see now the amount of mechanical disadvantage, a degree of disadvantage that my bicep would have. And you can also see that that forearm is not vertical. You can see the weight is not directly under my elbow.
Mhm.
So that means that I'm going to have, I'm not going to have as much load on my forearm as I would if that forearm was horizontal, but it's already more than it would be if it was vertical.
Okay.
Times the 9-fold magnification. So now we're talking a tremendously increased magnification. Now this next slide, I have my arm on a tabletop. And you can see that if I were to lower my forearm all the way down, my forearm and my upper arm would be completely horizontal, completely perpendicular to gravity. And in the previous episode, we talked about moment arm.
Yes.
The distance between the elbow and the weight. So you can see that the distance between the elbow and the weight here will be much greater than it would be on a preacher curl. And that would be greater than it would be if it was vertical.
Mhm.
So we're talking about the magnification of force. And so when you're doing a preacher curl, you have two magnifications. The magnification of the fact that the forearm is not vertical and the magnification of the mechanical disadvantage. The problem is that the magnification of the mechanical disadvantage is 9 to 10 times greater, which is significantly greater than the degree of angle of that forearm in the starting position. So what might normally seem like a small increase of magnification is really a significant increase in magnification. So now here I'm going to show you 6 slides taken from a video where you can see a guy doing a one-arm preacher dumbbell curl. So you can see on slide 1 and 2 there, he's just doing his thing. He's just going through the motions. All of a sudden on 3 and 4, you can see he's at the bottom, mechanical disadvantage on number 3. Number 4, look at the way that bicep has now slid up his arm.
Mhm.
He just snapped his tendon. Where? When the elbow was nearly straight. Why?
Right.
Because of mechanical disadvantage combined with the fact that his forearm was not vertical when he started.
Mhm.
Slide 5 and 6 is him, of course, jumping off the bench, cringing in pain. And now he has to deal with probably the surgical reattachment of that bicep tendon. And who knows how many months of healing, and who knows if he'll ever be quite the way he was before.
Right.
Okay, so it is ridiculous to think that a preacher barbell curl is, when I'm talking, by the way, a preacher barbell curl with free weight, I'm
Yeah.
not talking about a machine preacher curl or a cable
Right.
preacher curl, because these offer different directions of resistance.
Yes.
When you're talking about free weight, you're talking about straight down. So the angle of the forearm relative to that straight down is what you'd be looking at. It is ridiculous to think that they're equally safe. Now, it might be equally safe if you're talking about a very light weight.
Uh-huh.
But once you get into a significant weight, and by the way, when you're training, you're always pushing the limits. That's the nature of training. You're pushing the limits, right? You're going to be tempted to go heavier and heavier. You're not going to get any notice, any warning. This guy wasn't getting any warning whatsoever. Hey, listen, on that next rep, your bicep tendon is going to tear. You don't know. It just happens, right? What we do is we tell you where the risk is. We tell you where to be cautious. And not only cautious in the sense of being, let's say, overly cautious, but in the sense of what's the trade-off?
Yeah.
There's a high risk here to doing this preacher curl, barbell dumbbell curl. And are you thinking that it's helping above and beyond what you'd be getting with a standard vertical upright curl? Now, here's what you need to understand. Whenever you add resistance to one end of the range of motion, you take it away from the other end. So what you will discover, if you haven't already discovered it, is it's heavy, very heavy at the bottom. And you probably instinctively know not to straighten your elbow. So you already stop short of fully straightened elbow, which means you're already losing some range of motion.
Yeah.
And then halfway through the range of motion, you realize it's actually easier than you'd like it to be.
Mhm.
It's challenging you less than you'd like it to, but you can't use a heavier weight, because if you use a heavier weight, it gets even harder at the bottom. And then when you get to the top of the range of motion, you get 0.
Yeah.
Whereas if you were to do an upright vertical curl, you have magnification from the mechanical disadvantage in the beginning. So you don't need more than that. You're already getting enough early phase loading. Then as the bicep enters more of a mechanically advantageous angle with the forearm, the resistance increases conveniently. In other words, it's heavier where you're stronger, right? And then as the mechanical disadvantage diminishes, because now the bicep tendon is pulling like this relative to your forearm, right? The resistance is also diminishing. That's why we say, if you're going to choose one exercise, the best one would be something that gives you more of a straight down direction of resistance. Now, in this next slide here, this is taken from my book. You can see me there in the book. It's black and white, but here it's in color. I'm wearing a purple shirt. You can see what I've done is I'm sitting in a slight incline bench, and I've positioned a board behind my elbows. That means my elbows can't go back. They are in line with my torso. And in figure A there, you can see that my forearm is not quite vertical. It's at about a 10-degree angle. Okay, so now compare that 10-degree angle to the 45-degree angle of a preacher curl. And you can see the difference between the magnification you get from that forearm being perpendicular to gravity. Now, if you wanted to incline this bench farther back and create a slightly higher or steeper angle to that, somewhere between this and a preacher curl, you could experiment with that. But keep in mind that the heavier you go, the more problematic and risky it becomes. So when you're doing this exercise right here with a 10-degree angle, not a 45-degree angle, you will discover that you can actually let your elbow go straight when the weight is around 20 pounds. Once you start getting to 25 and 30, excuse me, and everybody is different, of course, you will notice that it gets more and more precarious in that bottom part of the range of motion. It gets more and more dangerous feeling. Now, notice that I'm using a hammer grip in this particular version, and a hammer grip automatically makes it safer. So if you're going to do a preacher curl or any degree of angle, you're better off doing it without the palm being up, because with a hammer grip, you have the assistance, the protection of the brachioradialis helping. But if you're palm up and your elbow is straight and you're overloaded at the bottom, there's a very high risk of bicep rupture. Now, the evidence of this is extensive. Look how many deadlifters tear their bicep, even though their forearm is mostly vertical. Again, it only takes 2 degrees, 3 degrees, 5 degrees, combined with the amount of weight you're pulling, combined with a mechanical disadvantage, to create enormous risk. And notice also that when you're doing a deadlift, it's always the palm that's facing forward that tears the bicep. It's never the palm that's facing back. Again, those 3 factors matter. Palm facing up, meaning the absence of assistance from the brachioradialis, elbow straight, meaning mechanical disadvantage, and a load that's greater than can be handled by that double magnification. So the question you want to ask yourself is very simply, do you want to gamble? Do you want to roll the dice? Do you want to try and tempt fate and see if you won't tear your bicep doing a preacher curl? And what is the benefit of taking that risk? There really is no additional benefit. You will not change the shape of your bicep by doing that. And, there are some people that talk about this thing called stretch mediated loading. And stretch mediated loading is essentially the same thing as early phase loading. So yes, there have been studies that have shown that if you load, and that's why we recommend early phase loading, right? The question is, how much can you early phase load before you tear the muscle? And keep in mind, we're only talking about flexion muscles here. Bicep, pectoral, hamstring, sometimes lat. These are the ones that reduce the angle of the joint rather than extending. The muscles that extend the joint have adapted to constant, always mechanical disadvantage. They never have a mechanical advantage. So that's why the tricep is striated, cross-hatched. Same with the quadricep. Same with the quadricep because it's an extension muscle. And this is called pennate muscle.
Pennate muscle, yeah.
Pennate muscle.
We did a video about.
Are cross-hatched, and so and the reason they're cross-hatched is because they've adapted to the fact that they always have mechanical disadvantage, whereas the straight muscle fibers like the bicep are particularly vulnerable. Okay, so that's it for the preacher curl, and I think the next topic is what? Deadlifts?
Yeah, but before we move that, because we want to make sure that we covered the physics part of it. Some people will say, okay, if the exercise is slightly risky, like many other exercises, it's not the problem of the exercise that person got injured. It's that person who didn't know how to use it, and he used a lot of weight that he could have prevented. So my question is that true? And my second question will be, what is the benefit you will get from a light preacher curl?
Well, if you use a light preacher curl that provides the safety of full range of motion with mechanical disadvantage and not tear it,
yeah,
you will find that you're not going to get any, or at least significant, challenging resistance halfway to the range of motion and none at the end.
Mm-hmm.
So now, if you want to, let's say, do a study and say, what would happen if you do partial range of motion, preacher curl, versus full range of motion, upright curl, go ahead and do that study. My feeling is I would rather do full range of motion. I feel better doing full range of motion. And it's not either or. That's the thing that's important to understand. It's not either or. So let's just say that I'm going to do a standing cable curl, alternating cable curl. I might start standing slightly in front of those two pulleys, meaning those pulleys are slightly behind me, which means that when my forearms go straight down, there is a slight backward pull on my forearm. It's not straight vertical. It's not straight parallel to my forearm.
Right.
It is challenging my bicep a little bit more than it would if it was straight down, right? So I can do that, and I do that. And I do with a relatively light weight. I might do 30 reps, and then I increase the weight. As I increase the weight, and I encourage you to experiment with this, as you increase the weight, you will notice how that influences that early part of that range of motion. When you have too much, even slightly too much, opposing resistance at the beginning of the range of motion when you are in mechanical disadvantage. So what I do is, as the weight goes up, I start to step back and I start to diminish the resistance in the early phase and increase it in the late phase. And I will also, depending on how heavy I go. So if you want to go really heavy on curls, like say a 6 or a 4 rep curl, what I tell people and what I do myself, and I encourage you to experiment with it, is I start pulling my elbow back slightly. I mean, some people even call that a drag curl. I actually pull my elbow back a little bit to create a bend in my elbow to gain a little mechanical advantage,
right,
bicep tendon to forearm, before I start bringing it forward and up, so that I can avoid that super high risk and still have a very, very heavy weight that allows me a full range of motion.
Mm-hmm. So it's not the fault of the exercise. It's the fault of the person.
It's physics. It's physics. I mean, it's, as I said, you can literally measure it. You can quantify it. Now, I joked last time is if anyone wants to bet me that they won't tear their bicep, please know that I was kidding. Yeah. Okay. Don't later say Doug told me to do this and I tore my bicep. But I will say that if you were to put your arm on a tabletop, and by the way, let me say that if you can put almost any weight in your hand when your forearm is vertical. You can put an 80-pound dumbbell in your hand and there's no risk, right? Because it's neutral. It's in the neutral position, right? So nothing is loaded either on one side or the other. If you were to then, with the palm up, if you were to lower that 60 or 80-pound dumbbell, as strong as your bicep might be in a standing version of a curl, the odds of you tearing your bicep tendon like that are enormous. Right. Enormous. You can quantify it. You can do the math on it if you want. But I'm telling you, you are literally begging for a bicep rupture. Now, of course, a preacher curl is less severe than that. But the point is the same. It's all about mechanical disadvantage. It's all about physics. It's all about magnification, double magnification of load. It is not about form, and it is not about stretching the bicep.